And thank you, Professor Marathi, for joining us too. Just I want to make sure, do you see what I share here?
Yes.
Okay. So.
My name is Reda Al-Zahar. I'm Hussein Al-Shuwaikat. And our project is to Infinity Project Frame and Body Design of Electrical Scooter. Our advisor is Mr. Pravez Mirati and the course instructor Dr. Pete Sherstem for 2020. Modern era, citizens have several methods of transportation. This can be personal car, train, bike, or even trolley. Growing population has made it difficult to find even proper car parking. In case of trains, hours of wait and even delay and rescheduling trains makes this mode of transportation a bit difficult. Similarly, bikes have their own limitations in being utilized as a method of transportation. In view the above mentioned constraints of various modes of transportation, a gap is identified and there is a union requirement to have mode of transportation which proves efficient and friendly to get around destination. After identification, the gap mode of transportation were reinvestigated. After multiple iteration, an electric cycle was shortlisted. This project aimed to combine both the parallel and inline scooter mode, which will enable both wheel to rotate about a steer axis and will improve the mode of transportation, having zero negative impact of environment. So electrical scooter are changing mode of transportation in cities and university campuses. This is being warmly welcomed to low price solution for small journey. Although electric scooters are being utilized in more than hundreds of US cities alone, there little is recognized about electric scooter. In our project, for making any project successful, strategic planning is fundamental step. The project was subdivided into the following main steps: initial research, 3D CAD modeling, and finally finite element analysis. Each step has its own importance and order of priority in order to keep the project on schedule and completed appropriately within the time. The main focus of this project was to design the FEA analysis of the structure. After the initial research, 3D modeling of system using Solidworks 2020 was started to make the structure lightweight, 1-inch square aluminum 1060 alloy was selected. Modeling was mostly done in Weldment model, and the rest of the parts, sheet metal and 3D features model were utilized. During 3D modeling, out-of-the-shelf and standard commercial parts were utilized. After 3D modeling process, FEA analysis were carried out of standing Solidworks simulation model, describing each step in success paragraphs. At the start, a lot of research was conducted on various types of scooter. A number of designs were revealed and their pros and cons of study. From the number of design, a combination of parallel and inline was selected due to an advantages over the rest. And focus research was further conducted to make the design simple, efficient, eco-friendly, and safe for use. Now I'll shift to Rida to talk about 3D modeling.
Rida, 3D modeling. The most distinctive means of making a 3D model is to take a simple object and extend it into a shape that can be refined and detailed. In this project, we used Solidworks software for 3D modeling. Each part was designed as per customer requirements, as you can see in this picture. Although there are various methods of creating a certain part, however, Solidworks model was mostly utilized to create structural elements. Here's a picture of the full structure. Custom moldment feature was defined with 1 inch square cross section. We designed the frame out of aluminum 1060 tubing cross section. We used aluminum because it is strong material with high modulus of elasticity, which is approximately 69 gigapascal. Body was created out of carbon fiber panels. We used carbon fiber because it is rigid, strong, brittle, and lightweight material. Finite element analysis. If a simulation can be incredibly supportive designing any project and ensures that design will function as planned, and this analysis minimizes the chance of failure. Although there are varieties of simulation software, ANSYS was utilized for FEA. The main parameters that the team was concerned with were the maximum stress, deflection, and factor of safety. Therefore, the Solidworks modeling was redesigned twice during this project. For the first and second designs, ANSYS showed high stresses and deflections at some areas. As you can see in the final design, the vehicle is safe under a force of 200 pounds with a safety factor of 1.5. The maximum deflection is calculated to be 0.3 to 8 inch under that load, which is an acceptable amount of movement for the type of project being simulated. Code of ethics. Fundamentals, principles, and canons of ethics were exercised while designing this project. Number 1. Using high safety factors to ensure that there is no fracture, so there is no injuries. Number 2. The project was designed via applying advanced engineering and professional knowledge. Number 3. The product was made of strong materials to make sure all health and safety parameters are there.
This is Hussein. The design advantage of the prototype. After design and finite element analysis are completed for the project, it is necessary to compare what advantages this design has over other designs. It is significant that the group designed something that would not only look professional, but it also had to be effective for its intended purpose. Major advantages achieved are as following. 1. Reduce weight due to use of aluminum alloy instead of ferrous-based alloys, while strength is also not compromised. 2. It is evident from above finite element analysis simulation. Factor of safety is between 3.2 and 9, which makes design quiet, reliable, and safe. 3. Use of electric motor makes this design eco-friendly and efficient. 4. The system has got advantages of both basic types of scooters, parallel and inline system. 5. The system is designed to be affordable to the most people, which makes this prototype quite inexpensive, whereas the cost of the first model is between $2,000 and $2,500. I'm going to talk about future improvements. Every new design creates opportunity for future improvements, and this design is not different. This project is designed while keeping this factor clearly in mind. One of the main future developments can be use of solar power for the functioning of the electrical components, including motors. Another thing that could be done to help improve the design would be further weight reduction through optimization of cross-section thicknesses. This is due to the fact that factor of safety is much higher in some areas. So from nodal analysis, thicknesses can be reduced to match, and overall factor of safety around 3 to 4. Finally, through extensive research, this design optimized while solving various issues discussed in abstract and introduction paragraphs. This research comprised of understanding of main functions and combinations of different types of cycles. This research gave us start-up kick of beginning the 3D CAD modeling. This research also familiarized us to the importance of finite elements analysis simulation, where actual physical testing could be difficult, time-taking, or even expensive. All design challenges were catered for and products provide via economy, efficiency, and safety. Furthermore, during all stages of design, engineering, and professional ethics were exercised in true spirit. I'm going to talk about acknowledgements. Successful compilations of this project could not have been possible without the help of several people along the way. We would like to thoroughly thank the advisor, Dr. Mirati, for comprehensive guide in the project. We'd also like to thank all, including the humanity, for valuable resources of research and web. And here are our references. If you want to see more information, you can visit these sites. And thank you.
Yeah, thank you very much to our presenters. So now we are open to the questions. Please, anybody has any question, please unmute your button, mic button, and you can ask now. At the meantime, I have one question for you guys. So what do you learn from this project? Each of you, of course, learned from this project.
For me, what I learned that I went deeper for ANSYS, how to deal with ANSYS. And actually, we plan to build this but because of the pandemic, we couldn't. Our plan actually to do the test, physical test on it, but unfortunately it didn't work. So we changed our plan to do it for ANSYS. I know it's not similar, but to give us similar results. That's what I learned. The ANSYS, I knew it was helpful.
Okay, thank you, Salim. So what about Hussein? What did you learn from this project?
Yeah, I learned how to use ANSYS, and I learned that with ANSYS I can abbreviate with all the software, not only ANSYS. Abbreviate a lot of things, like I don't have to use all the deflections equation and all the equations. I just can do it in ANSYS simulation and make it easier.
Thank you. Hussein, can you say something? Your mic, please. Your mic is not working. So your mic is not working. I can hear. Anybody can hear him?
No, yeah, like problem with the connection, I think. Not sure.
Okay, that's fine. Okay, yeah. Now his mic. Okay, we can't hear you. No, okay, that's fine.
I can let him use my mic if you want to.
That's okay. That's fine. Okay, no problem. So anybody has any questions to this group, please? What happened? I heard something.
Hi. Yeah, this they had a decent effort on coming up with a design, and I like the comment that at the end, you know, the acknowledgement comment as far as thanking the humanity for the World Wide Web. Yeah, I like also to thank the humanity for World Wide Web. That's good. That's a lot of information, but it's also making our lives, the professors, much harder now to come up with our own, you know, problems for exams, so that it will not be there out there on the web, and so that we're creating more knowledge out there as well. So yeah, that was an interesting comment.
Okay, yeah, okay. Thank you, Parviz. So there's one question in the chat room, guys. Can you answer that? And that could you show the FEA boundary conditions and result again?
What was the question?
Yeah, the question is, could you show the FEA boundary conditions and the result again?
Who did the answers?
Yeah, 1 second. Sure. Oh, sure.
Some problem?
I try to share my PowerPoint, so okay.
Okay, just maybe okay.
Is this one?
Yeah, what are the boundary conditions here?
So we are looking for the deflection, for the deformation. So if you see deformation here, it's the maximum is 0.328, and for this one is the force that we apply is 200 lb, 200 pounds. So Yeah, that's what we have here.
Okay, and thank you very much. And so, any other questions for this, let's say, people, please? So there's one question again, but you applied it over the entire plate surface. Is that correct? In that boundary
Yes.
condition? Okay,
Yes.
yes, okay. Okay. Okay, so we'll conclude this session here. Thank you, everybody, for attending this conference. The next presentation will start at 10:30.